Hi, welcome to Database Management System video lecturing. In this video, we are learning about the concept Relational Data Model and characteristics of relation. The topics which we are discussing in this video, first topic is Relational Data Model. Second topic is relational model notations, and the last topic is characteristics of relation. The first topic is relational data model. In this relational data model concept, we are learning about the tuples. Second topic is we are learning about the attributes, we are learning about the relation, and we are learning about the domain. There are basically informal and formal definitions are there. Based on that informal and formal naming conventions, we are representing a relational data model. Now, we will have a meaning of what is a relational data model. Basically the relational data model, it represents the database. The database is nothing but it is a collection of relation. So that collection of relation total together we are calling it as a relational data model. So this relational data model concepts or database is a collection of relation concepts, which will be represented in this figure. This figure will give a clear picture of a relational data model. Basically this particular student, this is the student relation where it includes name, SSN, home phone number, address, office phone number, age, and as well as GPA. These table which will going to give the clear attributes, that is we are calling it as column header. In the informal definition, we are calling it as, instead of relation we are calling it as a table. So instead of attribute we are calling it as a column header, and then column header, and informally we are calling it as a values which are inserted into that attributes. So that are all we are calling it as a informal definitions. But in case of formal definition, or this formal definition, we are calling it as that instead of table name we are calling it as a relation name. So this one is the relation name. All the table name we are calling it as now onwards relation names. And second one, here we are calling it as a column headers of the particular table. So here we are calling it as a attributes. So in the formal definition we are talking about we are calling it as now onwards attributes instead of column header. So this particular value of an attribute, or a particular rows in that table, each row we are calling it as a tuple, or set of rows we are also calling it as a tuples instead of values, or rows, or we can also call it as rows. Each row we are calling it as a tuple. Okay. Now, we will have some definitions about what is meant by a tuple, and what is meant by attribute, and how we can define this attribute, and what is the meaning of this relation, and what is the meaning of a domain. So this I have left it out in the formal definition. So we can next the values we are also calling it as a domains, or data type we are also calling it as a domain value. Okay. Now definition of tuple. The tuple is nothing but a row in a relation, we are calling it as a tuple. So for example here, Benjamin Bayer, SSN number is there, and home phone number is there, address is there, and office phone number does not existed, which is represented by using a null value. Age is written, and GPA so is written, so that particular value of an attribute, so that we are calling it as a tuple. Or so like that, how many number of rows are entered in this relation, those are all we are calling it as a tuples. So a particular row in a table we are calling it as a tuple. Then attribute. The attribute is nothing but, it is informally we are calling it as a column header, where it represents the meaning of or classification of our particular attribute value of an table. Like for example, student is there, student is having a name, SSN, home phone number, those are all we are calling it as a column header of that particular table. In the formal definition we are calling it as an attribute of a table. So next one is relation. So the relation is nothing but, so we are calling it as a table, or the table name itself we are calling it as a relation in the formal definition. Relation is nothing but a table header or table name, we are calling it as a relation. Here in this example, the student will be the relation name. Similarly, so the attribute which I have told, no, the attribute is nothing but the description of the table or description of the relation, we are calling it as a attribute. The description is nothing but, here the student will be having a name, student will be having a SSN number, student will be having a age, student will be having a address. These are all we are calling it as an description of that particular student or description value of that particular student, that we are calling it as a attribute. The description of a relation we can also call it as attribute. The relation is nothing but the table name itself, we are calling it as a relation name or relation. Then the last one is domain. The domain is nothing but, so the data type describing the type of values that can appear in each column is called a domain. Remember, so redefine the domain definition. The data type describing the type of values that can appear in each column is called a domain. So I will give example. So here the domain of EID or domain of name, if I written like this, so which includes the data type which is described for this attribute, the data type which is described for that particular attribute, or the format which is described or logical definition of that particular attribute. For example, here if I declared it as a variable character, then this variable character is the logical definition of this domain attribute. Okay. So for example, next if I say domain of age, okay, domain of age, then age is described in integer. Integer is nothing but this is also a logical definition of that particular domain. So like that, the logical definition, whether it is correct based on this definition or domain attribute value, so that will depends on this logical definition. If it is a variable character type or integer type or character type or data, what type of data type it is, whether is it a valid data type or invalid data type, that will gives a clear picture of the domain. Okay. So the domain is nothing but, I told, where domain D is nothing but it is a set of atomic values which includes, that meaning atomic is nothing but each attribute or column which are accepting a single value, that is the meaning of atomic value. So that is each domain can, which will going to describe the logical definition and format how this domain value should be and what data type which has been described for that attribute or column. Then that is a logical definition which will going to specify the data type of an attribute, and as well as the format which will going to indicate how physically that value will going to store or will going to save in the memory location. That gives the clear picture about the domain. Okay. This is about the definition of the domain. So that is So once again I will repeat the definition. The data type describing the type of values that can be appear in each column is called a domain. This is about the formal definition of a relational data model. So that is, in the informal definition we are calling it as a table, column header, values and rows, but in the formal definition, instead of table we are calling it as a relation name, instead of column header we are calling it as a attributes, instead of rows we are calling it as a tuple, and domain is nothing but value and as well as along with the data type and as well as format, that is we are calling it as a domain. So in this particular table, this figure I have referred from the textbook, that is DBMS textbook, which is written by the Nawate. Now we will try to learn about the relational model notations. The relational model notations are nothing but how we are presenting or what type of symbols or notations we are using to represent the relational models or a relation. So that are all we are describing under this relational model notations. The relational model notations, the first, so we will start with how the relations will be representing. All the relations will be represented by using a capital letter R. That R indicates that a relation name, and where A1, A2, capital letter A1, A2 up to AN, which will going to represent in the schema of a relation, that is, that we are calling it as an set of attributes of that particular relation R. So that is, we are calling it as a schema of a relation. And then second, R is nothing but, I told initially, this is the name of a relation, and where A1, A2 up to AN are the attributes of that relation that will be represented in the form of R of A1, A2 up to AN. For example, you can see with the example how we are representing a relation with the one small example. So here there is a student relation. The student relation includes the USN, so USN, comma name, comma age, comma address. So this is one small example. With this example you can see where R is nothing but student, A1, A2, A3, so that are all, so these are all the attributes of that particular relation, that is student. In this example there are 4 attributes are there. First one is USN, second one is name, third one is age, and the fourth one is address. So this format we are representing in the notation R of A1, A2 up to AN, where R is nothing but, so which are given here example, the relation name, and A1, A2, A3 up to AN are the attributes of that particular relation. So small r of R, a specific state, that is nothing but a value or a population of a relation R. This is nothing but it is a set of tuples or rows which will be indicated by using small r of R, where you can see here small r of R is equal to T1, T2, T3 up to Tn, where each Ti is nothing but tuples which are stored. For example, in the student table we may have values like, for example, USN is there, and then name is there, and age and address. So these are all attributes we have. So each and every attributes we are having a 4CB 18IS, so 003, and name might be Anusha, so and age is 20 and address is Mangalore. So this is one example, and similarly second example is 4CB 18IS 004, the name is Ananya, so then age is 20 and she is from Udupi. So these are all some set of R of R, where it is represented R of R, where this is the T1, this is the T2 up to so you may have tuples, and here each Ti will represents the value V1, V2 up to Vn, where each Vj is nothing but element of a domain Aj, that is element domain of Aj is indicates. So I told domain is nothing but a data type, and along with respect to the data type we are going to store the values, that is V1, V2, V3 and V4. So that is, for example, domain of USN, that domain of USN is in the form of variable character. That variable character is logically, so which will be represented, that is atomic value of that particular attribute. Okay, so that will going to describes the type of value that can appear in each column, that is represented by using a logical definition. So where it is an variable character type of value, so that is attribute name is USN. So where we are going to store this particular value, that is 4CB 18IS 003, 004, so on. So this is about the V1, V2, V3 and V4, V5, like that, domain of name, domain of age, domain of address. With respect to the data type, we are storing the value into the table. So then, so there is the letters Q, R, S, so which will going to denote so the particular relations. Always the relations will be represented by using a capital letter. So the capital letter represents here. So always the relation name should be in the form of capital letter. Q, R, S are the example. And then one more notation we are using, the letters, small letters Q, R, S, which will going to denotes the relation states. Okay. Then the letter, small letter T, U, V, which will going to denotes the tuples like T1, T2, T3 or U1, U2, U3, or small letter V1, V2, V3, that are all which is going to denotes the tuples. Now I want to stress what is meant by a relation state or relation instant. So just we will try to understand the meaning of relation state and or relation instant. So this is what we have discussed till now, that are all notations which we are representing for a relation. So now So what is meant by a relation state or relation instance? The relation state is nothing but it indicates the current content of a relation at any given instance of a time. We are calling it as a relation state. Means, so for example, you can see in the figure, this is a one scalar relations. In this scalar relations, we are having attributes like SID, SNAME, rating, age, and along with that each attribute will be having a set of values. Those set of values together we are calling it as a relation state. For example, so current content of, so this particular Sailor stable that is relation state, means at this current state, so we are having a 3 tuple values in this table, therefore so that we are calling it as a relation state or relation instant. Okay, means this is the definition which indicates the current content of a relation at a given instance of that time. In this particular time, so we are having a 3 tuple values in this particular Sailor's table, therefore this is what we are calling it as a relation state or relation instance. This is about your relational model notations and as well as relation state. Now the last topic is characteristics of relations. Basically there are 3 characteristics of relations are there. So one by one we will see the all the 3 characteristics of a relation. So what a relation should be, how the relation should be represent. So first characteristics of a relation is ordering of tuple in a relation R of R, which means, so whenever we are inserting the value into the table, like for example R of A1, A2, A3 up to A4, let us consider this is the attribute of a table where we are inserting the value into the table. Like consider, so A1 value, A2 value, A3 value and A4 value. So there is no order, so we are maintaining for the, or either in the ascending order or descending order for the tuples. All the tuples, so we are inserting into the table in the table formats. So that is the meaning of ordering of a tuple in a relation. For example, if you are considering the employee table, so in the employee table we are having a employee ID, employee name and employee salary, employee department number. So if whenever we are inserting the value for this employee table, the order might be a different. For example, employee ID 3, employee name is XYZ, the salary will be a 20,000, maybe he belongs to a department number 1. Then so employee ID 5 will comes ABC and he is getting a salary 15,000 and he might be belongs to a department number 2. So then employee ID 1 will comes, so UVW, so then he is also getting a 20,000 of salary and then he belongs to a department number 1. So when we can see these values, the tuples which we are inserted for this table, which are all not in the form of either in the ascending order or else in the descending order, means there is no any hard and fast rule. So to enter the tuples in a relation, so we have to insert the value into the table like in the ascending order or in the descending order, but all the value will be in the form of a particular table format. Like for example I told, so which will represents the columns and as well as rows manner, we are inserting the value into the table. That is about your the characteristics of first characteristics of a relation, that is order of a tuples in a relation. The second characteristics of a relation is ordering of attributes in a relation schema R. The ordering of a relation, so and values within each tuple means, so whenever we are, for example we are created the table in this format R of A1, A2, A3, A4. Okay, so now when we are created the table in this format, then so the insertion of the value or ordering of the attribute, how this ordering of the attribute is like A1, A2, A3, A4. then the value which we are inserting into the table, that value or a tuple value should also be in the form of like V1 and V2 and V3 and V4, because the domain of these attributes, that is domain of A1, so this should be, that is, if it is a data type is variable character, then I have to insert a value V1 that should also be a variable character data type value. So if I am talking about the domain of A3, if a domain of A3 is date, okay, then my V3 value should also be in the form of date. So if it is missing, like for example, instead of date, if you are inserting the value like integer value, then so there will be a insertion error, or where the domain attribute error will be displaying. So therefore, so that whatever the order we are created over here, in the same order, so then we have to insert the value into the table, else it is a meaningless when we are started to inserting the value into the table. That is what we are calling it as the second characteristics of a relation is ordering of an attribute. How we are created the table or attributes in the same order, we need to insert the tuple value into the table. If order is missing, then so there will be an error message which will be, or it won't give a meaningful, so when we are inserting a value for that particular attribute. So then third characteristics of a relation is values and null values in a tuple. In case when I am talking about values and null values of a tuple, each value in a tuple is in the form of atomic in nature. For example, means so all the values which we are inserting into in the table format, so then those values are not divisible. Okay, that is nothing but, so that is atomic in nature. So hence, so we can't insert the value for the composite attribute and multi-value attribute, so in this particular table. So the values of some attributes within a particular tuple may not be known, or else may not be applicable for that particular tuple. So that cases we are calling it as a special value. Those special values we are representing it as a null. For example, so if you are talking about the student table, okay, so in the student table, so we are having a attribute like name, okay, USN, and then age and mobile number, and then we have a PAN card number, and then so we have a driving license number. So in that case, when we are inserting the value for this particular table, where we are having a student name, so for example XYZ is the student name, we have a USN of that particular student, so 4CB, so 17IS or 18IS 003, and age will be a 20, and mobile number will be a, so digits of mobile number, he will be having a PAN card number AMP W89, okay, but he don't have a driving license number. In that case, we will be keep this particular tuple value or attribute value blank. So when we will move to the second, next one more tuple value, so that particular student will be having a mobile number, and as well as he don't have a PAN card number, but he is having a driving license number like KA to 2020, okay, and then followed by a license number. He will be having a license number, but he don't have a PAN card number. These kind of attribute value which can be represented by using a null in the table, or else the value is not applicable, the value is not mandatory, or else the value is unknown to that particular tuple. In that case, those values we are representing it as a null. So this is the three characteristics of a relation, so one by one, that is values and null values in a tuple. That is a meaning of last characteristics of a relation.